Okay, so here is an upper triangular matrix. Now I kind of didn't line these numbers up real well. Then when I circled them, I did even worse. But I'm going to indicate the numbers on the diagonal by overwriting them in yellow. Okay? So the determinant of this matrix is just 2 times 5 times 2 times 4 times 5. 2 times 5, that's 10, times 2 is 20, 80, 400. Okay? That's it. We calculated the determinant of this 5 by 5 matrix in just a few seconds. Okay? Now if the numbers are bigger or have more significant figures, yeah, take a little more than 5 seconds, but very easy. All you got to do is multiply. Okay? Now, why does that work? There are a number of answers to that question. I'm not going to answer them right now because we didn't answer them in class. But if you expand this in minors, you'll get a pretty good idea of why. Okay, one other thing I mentioned on the homework I got last week. People were doing something like this. 2, 3, 5, 7, 9, 2 with a T up here. They distributed that T through here as an exponent, which is totally the wrong thing to do in any case. Even if it was an exponent, that wouldn't be right. But they kind of distributed through and just put the T in all the numbers. Seemed like a sensible thing to do. I can understand that. But has nothing at all to do with the question that was asked. Now, the reason maybe people didn't know what to do with this is they didn't take time in class to introduce this idea. Because I'm talking fast enough in class. You're picking up, if I talked any faster, you'd pick up a much smaller percentage of it. So I left that as something to read because it's very simple. Okay? And I noticed that, I have some very good students in the class, and it seems like the very good students are the ones that did that. Okay? I have a lot of very good students. Almost everybody that handed in the homework. The rest I'm not sure about because I haven't seen the homework, but anybody that handed in the homework pretty much did that. Okay? Well, just a word about initiative. You don't know what this means? Did you read the section? If you didn't read the section, it's not my fault that you don't know what that means. Okay? And I understand, I didn't always read everything I was supposed to read. I totally understand it, but then, of course, I didn't make grades quite as high as they would have been if I'd have read everything. And you might be in the same position. So you want to read everything. What this means is the transpose, explained very well in your book with examples, and an idea that, at least at this stage, because you don't really know what it's used for, is a very easy thing to do. And it just means your rows become columns and your columns become rows. So the row 2, 3, 5 becomes a column 2, 3, 5. The row 7, 9, 2 becomes the column 7, 9, 2. And as soon as you've done that, then the column 2, 7 becomes the row 2, 7. The column 3, 9 will have to be the row 3, 9. Column 5, 2 will be the row 5, 2. So we switch rows and columns. Then you get to the proof of something that I think you were asked to prove, and nobody did. If you were asked, I don't remember seeing anybody having proved this. Don't remember for sure if that's one of the things you were asked. That AB transpose is equal to B transpose times A transpose. Okay? Now, the reason you switch the order of these things is when you do the transpose, rows and columns get switched. And if your matrices don't have equal dimensions, remember the matrices can be multiplied as long as the rows of A are as long as the columns of B, right? Well, when you switch rows and columns, the rows of A transpose don't necessarily match the length of the rows of the columns of B transpose. Okay, but the rows of B transpose were the columns of B, and the rows of A transpose were the rows of the columns of A transpose were the rows of A, and they match. The rows of A have same length as the columns of A transpose. The rows of B have the same length, the columns of B have the same length as the rows of B transpose. So that the length of a row of A multiplied by the length of a column of B are the same. It follows then that the length of a row of B transpose and a column of A transpose will be the same. You need to think through that, but it's very obvious if you just write it out and, with different dimensions and play around with it a little bit. So this is actually quite easy to prove because you're multiplying all the rows by all the same columns, except that the rows from over here become columns over here, and the columns from over here become rows over here, but they still match up. You need to work that out. I could stand here and say it all day, even if I said it well, which I didn't. You need to convince yourself of that. So it's an important idea. It will be much more important later.